Lesson 4 is on interpreting graphs. This is kind of a fun one. So I found this example, and this graph is actually not the greatest graph, and I'll explain why. What we see here, this is the height of water in a bathtub, and this is time. And I know there aren't any numbers on this graph, but what we're actually going to try and do is imagine having a bath, and this is the height of the water in the tub. So, when the line's going up, obviously the water is getting higher in the tub. And we're going to try and interpret what each line segment actually means. And I'll explain why this isn't the best drawn graph that I've ever seen. So what we have here from A to B, so this is how we would interpret this graph. We would write down what is on each line segment. So for example, A to B, I want to comment on what I think this line is about. So if you can imagine, I think one of the first things you do is you would probably turn the water on. So I think that this is just going up because the height of the water in the tub is being filled. Because the line is really steep, we could say that the water is probably, going really fast into the tub at that point. When it's flat from B to C, these flat lines are going to just explain that the height of the water is not going up or down, but time is actually passing. So maybe this is the moment where he's turned the water off and the water is just kind of staying at the same level, and maybe he's getting undressed and getting ready to get in the tub. Then if we look back up here from C to D, this is what I don't like about this graph. It goes vertically straight up. So that means there was no time that passed at all, and the level of the water did jump up. So I kind of think that this is supposed to be where he jumps in the tub, but he must have done it really fast, and the water in 0 seconds basically went up higher. So the tub was kind of full, and then he jumps in, so that's why the level of the water seems to go up higher, because he got in the tub. And then we see this long line here that is flat. So these graphs are supposed to be suggesting that the height of the water isn't changing at all, but the time is passing. So I think this is probably representing when he's just sitting in the tub. I think if he was moving around and washing himself, this would be going up and down. But I think he just might be just sitting in the tub having his bath. And then from E to F, you can kind of think about what would be happening here. The water is slowly starting to go down. So maybe he's sitting in the tub, and if you think about when you have a bath, maybe he just pulled the plug and the water starts to drain slowly. So notice that I'm commenting on every single line segment that's there. F to G, again, it's like a vertical line over here, so maybe he just jumps out of the tub now. And then there's one last segment here, and this is going kind of slowly. So the water, I think, filled the tub faster than it's draining. So from G to H, the rest of the water just drains out of the tub. So we're just trying to make some sense out of the graphs that we see. And that one's kind of a silly one, but the one here, so a distance time graph. We'll have a little bit of practice on these. So distance time, so if the distance away from an object or away from your house or away from a school, if it starts at 0, so I'm thinking that we already started a little bit away from home or the wall or whatever this line segment here represents. We're starting away, and then we're walking further away. And when the line isn't very steep, it suggests that we're not going really, really fast. So maybe slowly walking away from a wall or away from your house. And then, so this is distance and time. Here, the time is passing, but you would be coming back towards something. So back towards the house or back towards the wall. When a line segment is just flat, it suggests that nothing is changing. So you're not getting further away or closer to the wall or the house. And so time is passing, but you're probably just standing there and nothing else is happening. A lot of students, when they see distance time graphs, right away they'll say, oh, Joey's walking up a hill. This doesn't have anything to do with elevation. So I really want to point that out. A lot of students will say, oh, he's going up a hill and then he's going back down the hill. This has nothing to do with that. This is how distance, further away you're getting and closer you're getting to a certain object. So if we look at example 2, state which phrase best describes each segment in the distance time graph. So no movement. I think the segment here, C to D, when it's flat, there is no movement happening. Time is passing, but maybe somebody is tying their shoe. So C to D, there's no movement. The fastest movement. So even though we're going away, we look at these lines here. See, this one from A to B is pretty flat. They're not going really fast there, but D to E is actually the steepest line because we're going in only 1 unit of time. We've gone 2 units of distance. Here, we go 3 units over 2 units of time. So D to E is actually the fastest movement. It's the steepest line. And the slowest movement is obviously A to B. That's not a very steep line right there. And then backward movement. So I guess if you're thinking that this is going away from the wall, this would be coming back towards the wall. So backward movement could be also D to E. Okay, and then the last example, this is about George going for a walk. So George, distance from home as he walks to school. Describe his walk. So again, students see this right away and they're like, George is walking up a really big hill. This has nothing to do with elevation above sea level. This is not anything about that. So this is just distance from home and time in minutes. So when we look at these lines, what I want you to do, this is, you're going to get an assignment on this as well. So what I want you to do always, if you don't have these A, B, C, D, E, I would really like you to label the endpoints of each line segment and then discuss what's happening in each line segment. How far did he go? How long did it take? Okay, and then from B to C, how far did he go? So from A to B, you've got to look at the side and look at these values over here. So don't just count the squares and say that he went 1, 2, 3, 4, 5, 6 meters, because that's not what that represents. Each meter or each square is representing 50 meters. So when I look at this from A to B, he went 300 meters and it took him, you might have to come across and make some marks on your graph. This would be 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes. So in 3 minutes, he went 300 meters. So he was going fairly fast. And then we could actually divide those numbers and say that he's going 100 meters a minute. That's the speed that he's going. But for now, let's just look at each line segment. So BC, when I look at B to C, a lot of students will say he went 500 meters. But I want to know from B to C only, from there to there, how far did he go? So he was at 300 already, and then he went to 500. So he must have gone 200 meters, and he was at 3 minutes, and then now he's here. So 4, 5, 6, 7. From this distance to this distance, we've got 4 minutes, and he went 200 meters in 4 minutes. So he was going a little bit slower. You can see the line from B to C isn't as steep, so he's walking a little slower. From C to D, I want you to understand that he actually stops. So he's not moving further or closer to his house. He's still kind of on his way to school, but from C to D, he has stopped. So I want you to also say how long did he stop for. So if that's 7, 8, 9, from 7 to 9, so it looks like he stopped for 2 minutes. And then from D to E, he's starting to walk again at a pretty good pace. So D to E, he started at 500 meters at D, and he went all the way up to 700 meters. So it looks like he went another 200 meters again in. So he started at 9 minutes, and then if I trace this down, I'm here. So that's 11, 12, 13. So from 9 to 13, we've got 4 minutes there. So he goes 200 meters in 4 minutes. So he's going the same pace as he was up above. So it's all about just breaking down each segment and trying to understand what's going on with each segment. Some students will say, well, yeah, he walked 700 meters to school. So that's kind of an overall picture. And it took him 13 minutes. That would be a nice final statement, but we want to break down each segment as we go.